I'm going to work out some miscellaneous exercises in integration. Miscellaneous exercises in integration. That's at the level of college and high school level. I'm going to work out 6 of these in the first go. There'll be more to come later. So the first one, we want to integrate e to the power 2x sine 3x dx, and we'll use the parts rule. So starting off, write down I for our integral. It'll be the first times the integral of the second, which will be minus cos 3x over 3, minus the integral of the first differentiated, which is 2e to the 2x, and the second integrated, which is minus 3x over 3, so that will become a plus. Carrying on from there, e to the minus 2x cos 3x over 3 plus 2/3, and then integrating again, that'll be e to the 2x times sine 3x over 3 minus the integral of 2/3 e to the 2x sine 3x dx. Right, carrying on from there, that'll be e to the minus 2x cos 3x over 3 plus 2/9 e to the 2x sine 3x minus 4i over 9. So I is equal to all of that. So bringing this term onto the other side, we have 13i over 9 equals, take the e to the 2x outside, and inside we'll have 2/9 sine 3x minus cos 3x over 3, and then finally I will equal e to the 2x over 13 into 2 sine 3x minus 3 cos 3x. That completes the first one. Now move on to the second one. This is the integral of x sine x cos x dx. This is not as hard as it looks, because some people will say, we've got 3 functions here, how am I going to apply the parts rule to that? Well, you don't need to do that, because this is actually just equal to 1/2 of x sine 2x dx, okay, because sine x cos x is 1/2 of sine 2x. So from here on it's not too bad. So again, we'll use the parts rule. So it'll be the first times the integral of the second, which is minus cos 2x over 2, minus the integral of the difficult of the first, which is 1, times the integral of the second, which is minus cos 2x over 2 squeezing the dx at the end there, which then becomes 1/4 minus x cos 2x plus the integral of cos 2x dx and continuing from there, that's 1/4 minus x cos 2x, and this integral here will be sine 2x over 2, and then tidying up we get put the positive term first, so that's sine 2x over 8 minus x cos 2x over 4. So that finishes the second one. Number 3. This time we'll have a definite integral of sine to the 5th x dx. Now first of all, we'll write that as by 0, and that will be sine to the 4th x times sine x dx. So we'll now write that as minus pi upon 2, 0, 1 minus cos squared x all squared and d of cos x, which equals, we'll take away the minus sign and reverse the limits and multiply out the bracket, so that would be 1 minus 2 cos squared x plus cos to the 4th x d cos x. And now remember, the variable for integration here is not x but cos x, so what this becomes then is cos x, so you integrate the 1, minus 2 cos cubed x over 3 plus cos to the 5th x over 5, and we just want to put in our limits, 0 and pi upon 2. Well, putting in 0 for the x, that becomes 1 minus 2/3 plus 1/5, and when we put in pi upon 2, each of those terms just becomes 0, and so our final answer will be 6 over 5 minus 2 upon 3, which is 8 over 15. That finishes the third one. Go on to number 4. This time we want the integral of, again, a definite integral of x squared log n of x. Some people still prefer to write log to base e of x, but it makes no difference. All right, what we'll do here is reverse the order for integrating by parts. It's much easier. So that will be log n of x times x squared dx. And now applying the integration by parts rule, it'll be the first times the integral of the second, which is x cubed upon 3 let's not forget our limits, minus the integral of the first log n x differentiated, which is 1 upon x, and x squared integrated, which is x cubed upon 3 dx. Evaluating the first part, that will simply be 8 over 3 log n of 2, because remember log n of 1 is 0, and then minus, simplifying that becomes x squared over 3, limits 2 and 1 dx. And so we end up with 8 upon 3 log n of 2 minus 1/3, which we've already got, and then integrating x squared is x cubed over another 3 between the limits 2 and 1, and that quite simply comes out to 8n, or 8/3 log n of 2 minus 7 over 9. That finishes the fourth one. Rule number 5, and this is pi over 2, 0, 3 dx over 13 plus 12 cos x. Now here we need to use a familiar ruse de guerre, which is let t equal tan a half x. Many of you will be familiar with that, I hope. This will give us, when we do the differentiating and switch the terms around, this will give us dx equals 2 dt over 1 plus t squared, and cos x equals 1 minus t squared over 1 plus t squared. And now substitute back into our integral. So that becomes 6 dt over 13 plus 12, 1 minus t squared over 1 plus t squared, close bracket, and 1 plus t squared here. Remember, we need to change the limits as well. Now you see, when x is pi upon 2, half of x would be pi upon 4, and the tan of pi upon 4 is 1. And when x is 0, t will also become 0. So that's our new limits. Multiplying all this out, let's see what we get. 1 and 0. This will quite easily simplify out to 6 dt when you've done all your multiplication and multiplied out the brackets. This will come down quite simply to t squared plus 25. Okay. Now we're going to use, this is the tan inverse integral. We'll use the standard integral, dx over b squared plus a squared x squared is equal to 1 over ab tan inverse ax over b. On many examination boards, that particular formula will be on the menu. So applying this, and here the a is simply equal to 1, and the b is equal to the square root of 25, which will be 5. So what this then becomes is 6 over 5, using all that, 1 over ab. Okay. The 6 is already there. The a times b is 5, and then that will be tan inverse x over 5, and the limits are 1 and 0. The bottom limit will make the whole thing 0, but the top limit will make it 6 over 5 tan inverse 1/5, and you can leave it like that. Just one more integral to do. Number 6, integral number 6, pi upon 2 and 0 cos to the 4th x dx. Here we just need a little bit of trigonometry. First of all, you can write that as cos squared x all squared dx, and then cos squared x can be written as 1 plus cos 2x over 2. That's all squared dx. So squaring that out, what do we get? We get 1/4, that's the 2 at the bottom, squared. Should be pi over 2, 0. Right, squaring out the bracket, that's 1 plus 2 cos squared 2x cos 2x plus cos squared 2x dx. Right, carrying on from there, it's 1/4 pi over 2, 0, 1 plus 2 cos 2x, and the cos squared x can be written as 1 plus cos 4x over 2, and then dx. And now we're in a position more or less to integrate all that. Let's get the constants together first. So you got 1/4 pi upon 2, 0. 1 plus a half will be 3 upon 2. Then plus 2 cos 2x plus cos 4x over 2 dx. So this will be 1/4. Integrating, that's 3x over 2 plus 2 sine 2x over 2 plus sine 4x over 8. The limits pi upon 2 and 0. Then putting in our limits, we get 1/4 3 upon 2, so there, and then pi upon 2. This one will become 0, and so will that one. So the 2 with the sine 2x and the sine 4x will vanish, and that's with the top limit. And when you put in the bottom limit 0, all the terms vanish. So we're just left with 3 pi over 16, and that completes the sixth integral.